Okay, let's practice some examples finding definite integrals now using the fundamental theorem of calculus. So for the first one, the integral from -1 to 2 of x squared dx. So the first step, what you want to do is you want to pretend as though these limits of integration are not there. So you want to find as if you were finding the definite integral, the indefinite integral. So the antiderivative of x squared dx, we know is technically going to be x cubed over 3 plus c. Now, we normally are going to let, for our purposes, we're going to let c equal 0. So because we're going to let c equal 0, this is just x cubed over 3 plus 0. But then we still have, now that we've found that indefinite integral, we have to take into account this is the definite integral. So we've got to find some place to put these limits of integration now. Now we've already integrated, so the integral symbol and the dx go away, so we can't write it on those. So because we know it's just plus 0, we don't need to write that out. So there are two common notations that we're going to use. So you can either use just a vertical line after your antiderivative and say that it's evaluated from -1 to 2. So you can use that one. Or you can write it as x cubed over 3 and put this entire integrand into brackets and say that it's evaluated from -1 to 2 that way. So you should use either one of these notations. Typically, I'm going to use the vertical line if our antiderivative only has one term. I'm going to use the brackets if you have more than one term. That's just a good practice to make sure that you're showing that everything, that entire antiderivative, is being evaluated from -1 to 2. So if there's only one term, though, it really doesn't matter. So either way, whichever notation you choose to use, then you finish the problem by using the fundamental theorem of calculus. So fundamental theorem of calculus says we evaluate b first, so this top number is going to be what we evaluate first. So we're going to evaluate our antiderivative, x cubed over 3, whenever x equals 2 first. So remember, these limits of integration are always going to be x equals blah and x equals blah if x is your independent variable. So in this case, we're evaluating x cubed over 3 whenever x equals 2. So this is going to equal to 2 to the third power over 3 minus, so that's the f of b part of the fundamental theorem of calculus, minus f of a is going to be evaluating our antiderivative whenever x equals -1 in this case. So -1 to the third power over 3. So simplifying this, we have 8/3 minus a -1/3. And so this becomes 8/3 plus 1/3, which is 9/3, which then reduces to 3. So something important to note, an indefinite integral will always be a function plus c. A definite integral will always be a number for our purposes. So if you have numbers on your integral symbol, which means you're finding a definite integral, you should always, in our class, you should always get out a number. If there are no numbers on the integral symbol, so if you're doing an indefinite integral, you should always get out a function plus c. All right, let's look at example 2 now. So the integral from 1 to 4 of square root of x dx. So first things first, let's rewrite this function. So this is the integral from 1 to 4 x to the 1/2 dx. So we did this antiderivative in the last section. So this is going to become 2/3 x to the 3/2 power. And we're going to evaluate that from 1 to 4. So substitute 4 in first. So this is 2/3 times 4 to the 3/2 power minus 2/3 times 1 to the 3/2 power. So 4 to the 3/2 power, so that's the square root of 4, which is 2 to the 3rd power. So that's 8, so we have 2/3 times 8. Minus 2/3, 1 to any power is 1. So minus 2/3 times 1. And so that gives us 16/3 minus 2/3, which is 14/3. All right, example 3. So the integral from -2 to 2 of x cubed dx. So find the general antiderivative first. So we know the antiderivative of x cubed is x to the 4th over 4. And we're going to evaluate that from -2 to 2. So substituting in 2, so this is 2 to the 4th over 4, minus -2 to the 4th over 4. So 2 to the 4th is 16/4. -2 to the 4th is 16/4. So we have 16/4 minus 16/4. Now we could simplify this to be 4 minus 4. But either way, something minus itself equals 0. So this one, this definite integral equals 0. All right, example 4. So the integral from -2 to 0 of x squared plus 2x dx. Or sorry, x squared plus 2 dx. So first let's find the antiderivative of this. So the integral of x squared is x to the 3rd over 3. The antiderivative of 2 is 2x. And we're evaluating this from -2 to 0. So then substitute in 0 first. So that's 0 to the 3rd over 3 plus 2 times 0. Minus, now substituting in -2. So -2 to the 3rd power over 3 plus 2 times -2. So it's important when you're doing this, remember that this negative is going to go through to both of those terms, right? So this becomes 0 to the 3rd over 3 is 0. 2 times 0 is 0. Minus -2 to the 3rd is -8/3. So minus -8/3. And then minus 2 times -2, which is -4. So that negative is going to go through to both terms. So then this just becomes 8/3 plus 4, or 8/3 plus 12/3. Or sorry, yeah, 8/3 plus 12/3. Which then is 15/3 or 5. And we're done. All right, let's look at example 5. So the integral from 0 to 2 e to the x dx. So the first thing we want to do is find our general antiderivative. So the antiderivative of e to the x is e to the x. And we're going to evaluate that from 0 to 2. So e to the 2nd power minus e to the 0. Well, e to the 2nd power we can't do anything with. E to the 0, however, we know is 1. So this just equals e to the 2nd power minus 1. And we're done. All right, and one more example. So the integral from 1 to 3 dx over x. So you can think of this as the integral 1 to 3, 1 over x dx. So let's think about our process here. We know that the antiderivative is just going to be finding the function whose derivative is 1 over x. So we know in this case that's going to be natural log absolute value of x. And we're going to evaluate that from 1 to 3. So this is natural log absolute value of 3 minus natural log absolute value of 1. So natural log absolute value of 3 is just natural log of 3. Natural log absolute value of 1 is just natural log of 1. And remember, using your exponent properties, natural log of 1 is 0. So we have natural log of 3 minus 0, which is just natural log of 3 for our definite integral.